Hello, my name is Sweba and I'm going to walk you through my two advanced technologies projects. So my project for term 1 was developing a voxel building system to help foster engagement in the arts. This is quite heavily inspired by Minecraft. Studies done on Minecraft's effects on children in educational settings show that it boosts creativity and encourages experimental thinking. Considering this alongside the objective of the project to create something that helps to foster engagement in STEAM, as well as the conclusions of the research review on the screen, it was concluded that creating a similar voxel system would in turn create similar effects in fostering engagement in the arts. So voxels are essentially three-dimensional pixels. They're used in a variety of different games, Minecraft, Teardown, for example, and also a lot of software. For example, Magica Voxel is quite a popular voxel building software. In the context of this project, the voxel is a custom voxel prefab. Just using the default Unity cube was also considered, however, as more voxels were being instantiated and more things had to be drawn on the screen in Unity, there were some performance issues, so later on this was changed to using a voxel prefab, which contains 6 face prefabs, which in turn contain an origin point, which is just an empty transform, and a quad. This worked well. There was a lot less performance issues and lots of voxels could be drawn onto the screen. The voxel prefab also holds a voxel functionality script, which has an array with a reference to all the faces in the prefab, alongside its voxel data scriptable object. Scriptable objects have been used in this project to contain data such as the voxel's specific color outside of runtime. The top right of the screen shows in-game UI for choosing different colors for the voxels. Attached to each of these buttons via another script is one of these scriptable objects. When you click on one of these buttons, it grabs the color held in the scriptable object and then applies it to the brush. This system specifically has been designed in a way where you can have as many colors as you want. All that is needed to make it functional is to have your variant of the voxel data object, and then using the corresponding script, attach it to the UI button. And so this is infinitely expandable. You can have as many colors, as many different configurations as you want. In the final version of the artifact, you have 3 options. You can erase voxels, you can paint voxels, which just changes their color, and you can place voxels. The pictures and the GIF on the screen show the different applications of this system. As you can see, it works in a variety of different angles, different rotations. You can rotate up, down, left and right, and also move the entire object up, down, left and right by holding Shift. This allows the users to have a lot of flexibility when creating things using this system, which is exactly what studies cite as such an important part of why Minecraft is so good in fostering creativity. Despite this flexibility, there are parts of the prototype that need work. Further work done on this project would likely see improvements to the UI system. Designing the UI in adherence with user-centered design principles would greatly help this. Using the scriptable object system that has been developed to add more customization options would also be quite beneficial. The implementation of a character controller so that users can engage with their models in different ways could also be extremely interesting. In this case, I think looking into voxel mechanization would be required in order to make it performant. And finally, consistent user testing so that issues with the project can be very quickly identified and resolved. The title for the second project of the Advanced Technologies module is Utilizing Gamification Patterns in the Development of a Web Game Prototype to Raise Awareness for Common Symptoms of Anorexia Nervosa. Anorexia nervosa is an eating disorder characterized by very low body weight, intense fear of gaining weight, and an extremely flawed way of seeing their own body. It is often cited as one of the most deadly psychiatric disorders, and studies find that around 10% of people who have anorexia nervosa die within the first 10 years of having the disorder. In the interest of spreading awareness for common symptoms of this disorder, this project aims to utilize common gamification principles to create a web game that teaches the users/players about the disorder and its symptoms. Gamification refers to the application of game design elements and principles in non-game contexts to motivate and engage users. It is generally cited as being useful in educational contexts. Notably, studies have shown that applying gamification elements to medical education results in higher levels of information retention and clinical reasoning skills. This is quite useful in the context of this project specifically, as it's intended to raise awareness for symptoms of a specific psychiatric/medical disorder. The prototype for this project, in its design and overall gameplay loop, is quite heavily inspired by job simulator games such as Papers, Please and That's Not My Neighbor. In both of these games, you have a rotation of NPCs that you have to analyze and gain information on, and then make a yes or no decision for. So because the gameplay loop is very linear, you see one patient, you review the information, you make a decision, and then the next patient comes in. A scene manager was implemented to control the overall flow of the game. Among other variables and references, the scene manager contains an array of patient objects. At the start of a rotation, the index of the array is taken, +1 is added, and then that corresponding patient data object, its data is taken from that object and given to all the other objects in the game. Once again, scriptable objects have been used to contain relevant data about the patients outside of runtime. In this context, relevant data is the patient's name, the patient's unique sprites, the unique dialogue options, its weight status, and whether or not the player character should refer them at the end of their rotation. At the start of every rotation, the information shown on the right that is in the patient data is taken by the scene manager and given to the dialogue system object. The player can click on any of these dialogue options and the answer is displayed. The information in the symptom sheet is taken directly from the DSM-5 TR criteria, which is the latest iteration of the DSM-5. The game has been designed and developed to be played in your browser. This is to maximize accessibility, which in turn helps to raise more awareness for these symptoms. Throughout gameplay, the scene manager makes note of the patients that you correctly or incorrectly referred. This data is then compiled at the end in the results sheet, as you can see on the screen. If the player makes one or more mistakes, the pop-up shown on the screen of "Did you check the symptom sheets?" shows up. If you get all of them right, this doesn't show up. This is to provide a very low stakes repercussions for getting a patient wrong. Further work on this project could see increased amount of patients being used in the rotation alongside a randomized patient rotation, alongside other means of getting information about the patients, maybe similar to Papers, Please or That's Not My Neighbor. And yeah, thank you very much.